Imagine you are the last human being alive, not on Earth, not in a city, not surrounded by anything you've ever known. You are floating, motionless, in the coldest, darkest, most perfectly empty corridor of space that has ever existed. There is no sun. There is no planet. There is no light in any direction, just nothing, stretching forever in every direction. And somewhere behind you, so far away you couldn't see it even if you tried, is home. And something is out here with you. You just don't know what it is yet. In 1977, humanity did something it had never done before. We threw a bottle into the cosmic ocean. Two of them, actually. Voyager 1 and Voyager 2, twin spacecraft the size of a small car, launched just 16 days apart. Scientists dressed them up with gold records, actual golden discs engraved with the sounds of Earth, whales singing, children laughing, the sound of rain, the greeting hello in 55 languages, like a love letter to the universe, like we were excited to be found. And for years, these two little machines drifted beautifully through our solar system, past Jupiter with its hurricane the size of 3 Earths, past Saturn and its rings that shimmer like broken glass in slow motion. Every image they sent back was more breathtaking than the last. The universe looked magnificent. It looked welcoming. That was the beautiful lie. Because here's the problem. No one told us what was waiting on the other side. For decades, the Voyagers kept traveling, farther than any human-made object had ever gone. Scientists tracked them every day, watching the signal get weaker, the data get slower, the distance grow to a number that stops meaning anything to a human brain. At its closest, the Sun is 93 million miles from Earth. That's already incomprehensible. But Voyager 1 kept going past that, past 10 times that, past 100 times that, past the orbit of Neptune, which is 2.7 billion miles away. And still it kept going. And then something strange happened. In 2004, Voyager 1 entered a region scientists had predicted but never observed, a place called the termination shot. This is where the solar wind, that invisible river of charged particles constantly blowing outward from the sun, suddenly slams into something. It slows down. It gets confused. It piles up like a wave hitting a seawall, and scientists watching the data from Earth went very quiet. Because this meant they were close to the edge of our sun's entire sphere of influence, the place where the sun's power ends. They called it the heliopause, the boundary, the last wall between our solar system and everything else. And in 2012, Voyager 1 crossed it. We became, for the first time in human history, interstellar. We had sent something into the space between stars, and what it found there was not what anyone expected. Here is something that should terrify you. The heliopause, the edge of our solar system, is not a fixed, stable, solid border. It moves, it breathes, it swells and contracts based on pressure from the outside pushing in. And what's pushing in from the outside is something called the interstellar medium, a vast, tenuous fog of plasma and magnetic fields and cosmic dust that fills the space between every star in the galaxy. That fog has pressure. That fog has direction. That fog pushes against our solar system the way the wind pushes against a soap bubble. And our entire solar system, our entire neighborhood, every planet, every moon, every piece of life we have ever known is just a thin bubble inside it. Voyager confirmed this. When it crossed the heliopause, the instruments didn't just register emptiness. They registered a denser environment outside than inside. They registered magnetic fields with different orientations. They registered a kind of cosmic static, charged particles raining in from every direction, accelerated to energies our sun could never produce. You feel safe on Earth because you are inside the bubble. But the bubble is under pressure, and pressure means it can pop. But it gets worse, because the boundary Voyager crossed is not smooth. Scientists studying the data realize the heliopause is turbulent, rippled, almost violent in its structure. The plasma on the outside doesn't gently press against the bubble. It churns and twists and creates magnetic reconnection events, places where the magnetic field lines snap and reconnect like broken rubber bands releasing stored energy in an instant. If you were standing at the heliopause, which you can never do, because it would kill you in ways we haven't even invented names for yet, it would look like a storm that never stops. A storm that has been raging since before the Earth existed. A storm that will still be raging long after the sun dies. When most people imagine interstellar space, they imagine nothing. A vacuum, a void, the ultimate absence of everything.